Question number 4. Recall that a magnetic field is represented using field line. I think all of us know that there is a magnet consists of north and south pole, and magnetic field inside and outside the magnet, outside the magnet from north to south, inside from south to north, and represented by this line. Identify the properties of a magnet, and properties of the magnet, it's written in the question. A magnet always has a north pole and south pole. A single north or south pole cannot be isolated. If you break the magnet into two pieces, you will have two magnets, and the two magnets consists of south and north pole. We cannot have north pole or south pole separated. A single north or south pole cannot be isolated. They always come in pairs. Opposite magnetic pole attract and like pole is repel. All of this is properties of a magnet. Breaking a bar magnet in half result in two new magnets, each with north and south pole. Recall the SI units for a magnetic field. The magnetic field, the symbol of magnetic field is B, and the unit for magnetic field is Tesla. Magnetic field is a vector quantity. It needs direction and magnitude. What about general properties of magnetic field? Magnetic field, they never cross one another. Magnetic field, they never cross. Okay, if we have a magnet like this and the magnetic field inside and outside the magnet, they not cross each other. They all have the same strength at the same distance from the magnet. What the meaning by this? If I need to calculate the strength at a distance 5 meters from the magnet or 5 centimeters from the magnet, and I calculate the strength at the 5 meters from another side of the magnet, the strength will be the same. Their density decreases with increasing distance from the pole. The density at 1 centimeter, it will greater than the density at 6 centimeter. If I move away from the magnet, the strength of the magnetic field will be less. They flow from the south pole to north pole within a magnet, inside the magnet from south to north, inside the magnet, and outside the magnet from north to what? To south. Outside the magnet from north pole to south pole. All of this related to question number 4, but we will make a quick revision about chapter 7. The first question, the magnetic force on a charge moves in a constant field. F, it's equal Q V B sine theta. F is a force measured in Newton. Q is a charge measured on Coulomb. V is velocity or speed measured meter per second. B is a magnetic field in Tesla, and the theta is an angle between V and B. The magnetic force on a charge move in a constant field, it always perpendicular to the magnetic field direction only, or parallel? Parallel not correct. The force is perpendicular. Perpendicular to what? Perpendicular to magnetic field and perpendicular also to velocity. So that our answer is C, always perpendicular on both motion direction and the magnetic field direction. Question number 2. What is the charge? Charge is Q and measured in Coulomb of a particle moving in 0.4 Tesla. Its magnetic field, uniform magnetic field with a speed. Speed is V in a circular path. The magnetic force exerted on that particle, magnetic force is F. We write the equation F equal Q VB. Circular path, it means theta equal 90 degree. If you need to write sine 90, okay. If you don't need, because it's equal 1, no problem. F is 1.2 multiply 10 to negative 9. Q Q we don't know, multiply V 4.5 into 10 power 4, then magnetic field is 0.4, sine 90 equal 1. I ignore it. We can divide by the number beside Q and calculate Q using your calculator. Fraction 1.2 into 10 negative 9 over 4.5 into 10 power 4 times 0.4. The answer is 6.67 times 10 to negative 14 coulomb. Question number 3. A negative 1.6 times 10 negative 12 coulomb. It's a charge. Particle moving with a speed is V. In the positive direction, enter a magnetic field. The magnetic field in two directions, X and Z. This is BX and BZ. What is the magnetic force F affects in the charged particle? We have two magnetic fields in X direction and in Z direction. Magnetic field in X direction doesn't affect with any force on this particle. Why? Because the particle move in X direction also. The particle move in positive X direction. And the magnetic field in X direction, they are parallel to each other, so that the magnetic field in X doesn't affect with a force on this particle. But the magnetic field in Z direction will affect with a force, so that affected with force, it's equal Q V B Z direction, and sine theta, it's sine 90. Q is 1.6 into 10 negative 12. V is 3.6 times 10 power 5. B in Z direction, it's equal to, the answer is 1.6 into 10 negative 12 times 3.6 into 10 power 5 times 2. ENG 1.15 into 10 power what? Negative 6 Newton. But this force in which direction? We can imagine magnetic field in negative Z. Negative Z, we can consider it's into this disk. Into the disk, it means X. Magnetic field in negative Z direction. And the charge is negative. And moving in which direction? In X direction with a velocity V. We use a right hand rule. My fingers with B inside the screen, my thumb to right side with positive X direction. The force effect on negatively charged with backhand, so that the force will be to down. The force to down. Down in which direction? In negative Y. Force equal 1.15 times 10 to the negative 6 in negative Y direction. Again, why I draw magnetic field is X not dot? Because it's in negative direction, inward. And the charge move in positive X direction. I draw the right side arrow. And this charge is negative. The force affects on negative with backhand, not palm hand. I put my fingers inside the screen. My thumb refer to the right side, the backhand to down. Down, it means negative Y axis. The answer is 1.2 times 10 negative 6 in the direction of negative Y axis. Number 4. A charged particle enter a uniform magnetic field as shown in the figure. As you see, magnetic field out of the screen. What is the direction of the magnetic force that will exert on this particle? We will use right hand rule again. My fingers out of the screen. My thumb up. Look to me. My fingers out, my thumb up. This is positive or negative? It's negative with backhand. In this direction. In this direction, you can make it with your hand. You will see the force in this direction. This direction means negative X direction. In the direction of negative x-axis. Again, number 5. A charged particle enter a uniform magnetic field as shown in the figure. Which of the following describe the motion of the particle as it enters the magnetic field? First of all, my fingers in or out? Out, yes. My thumb to the left or to the right? To the left. So that I will make my hand like this. My fingers out and my thumb refer to the left. Positive charge, it means the force up. I draw the arrow refer to up, the force direction. In this case, this particle will move in the circle around this force. It starts change direction between V and F. It will move in this direction between V and F in a circular path around F. It will move in a circle clockwise direction. Motion in straight line? No. Clockwise circular motion? Yes. Number 6. Which of the following is an equivalent unit of Tesla? The force affects on the wire carrying current ILB. B, it's equal F over IL. F measured in Newton, I in ampere, L in meter. We can consider it Newton times ampere to the power -1, meter to the power -1. So that this is correct choice. Number 7. A charged particle is moving in a uniform magnetic field as shown in the figure. What is the type of the particle charge? This particle moves in a clockwise circular motion as you see. If I draw the particle at this point, velocity refer to the right side and the force refer to what? To the center of the circle. It means I need my thumb to the right side, okay, and my finger inside the screen. I make it like that? No. I will reverse my hand like this. Now my fingers enter the screen, into the screen, my thumb to the right. As you see, my backhand refer with the force. My backhand refer to the force effect on negative or positive charge. Yes, correct, with negative charge. This charge, it must be negative. Question number 8. A proton is positive, enter a uniform magnetic field. Make the proton moving in a circular path as shown in the figure. What is the direction of the magnetic field line? As you see, this is proton, it's positive. If I draw positive charge at this point, velocity will be to the right side and the force toward the center of the path. I need to make my palm hand down. I need to make it down and I need to make my thumb to the right. Can I make it like that? It's not correct. My palm hand down but finger to the left. If I reverse my hand, also not correct. It means my fingers into the screen, not correct choice. My finger, it must out of the screen, outward. If I make my fingers out like this, as you see my fingers out of the screen, palm hand refer to down with the force direction, and the thumb in the same direction of V, it's correct. In this case, it means magnetic field, it dot, it means out of the screen or outward. Number 9. At what angle the magnetic force on the proton will be greatest? It will be greatest if the angle equal 90, because sine 90 equal 1. The greatest force effect on a charge moving on the magnetic field when the angle equal 90 degree. Question number 10. A proton enters 0.65 Tesla, it's a magnetic field, uniform magnetic field at an angle 30 degree relative to the magnetic field. What is the radius? R equal what? In meter, and we can convert it to centimeter, of a helical path that the proton will travel if you know that it travels 1.2 millimeter times 10 to the negative 3, its distance, horizontal distance of its path during 2.5 times 10 negative 10 second time. We have distance and the time so that we can calculate V. It's equal D over what? Over T. But which V? The velocity make the proton move forward. This is parallel velocity. Parallel velocity, it's V cosine theta. In helical path, we have two velocities. V parallel, it named V cosine theta, and V perpendicular. V perpendicular make the proton move in a circular path. It's equal V sine theta. We have theta, we have D, we have T. We can calculate V. So that velocity, it's equal D 1.2 into 10 negative 3 over time 2.5 into 10 negative 10 cosine 30. 1.2 into 10 negative 3 over 2.5 into 10 negative 10 cosine 30. It's equal 5.5 times 10 power 6 meter per second. He asked about radius. Radius equal mv over qb. Which v? V perpendicular. It's v sine theta. V perpendicular, v sine theta. We have m of proton. Mass of proton is 1.67 times 10 negative 27 kilogram. It's a constant. V, we have it 5.5 10 power 6 sine theta, it's sine 30 over q of proton 1.6 times 10 negative 19. B is 0.65. Use your calculator. 1.67 into 10 negative 27 times it ends times sine 30 over 1.6 into 10 negative 19 times 0.65. The answer is 0.445 meter. Choice in centimeter. How to convert it from meter to centimeter? Multiply 100. Multiply 100. It's equal what? 4.5 centimeter. Number 11. A charged particle with a charge is Q, enter a uniform magnetic field. The charged particle follow a helical path with the radius, it's R, 2.5 meter. If the perpendicular component of the charged particle momentum is B, perpendicular momentum, 1.6 times 10 negative 12 kilogram times meter per second. What is the magnetic field B? R, radius, it's equal mv. Which V? V perpendicular over qb. All of us know mv, it's B, it's a momentum. So that radius equal perpendicular momentum, this sign it means perpendicular, over qb. He asked about magnetic field B equal momentum, perpendicular momentum over q multiply r. B equal 1.6 into 10 negative 12 over q is what? 3.2 into 10 negative 12 times radius 2.5. Using your calculator, 1.6 into 10 negative 12 over 3.2 into 10 negative 12 times 2.5. It's 0.2 Tesla. Number 12. Three charged particle with the same charge, Q1 equal Q2 equal Q3, and different masses, M1 greater than M2 greater than M3, enter perpendicularly the same constant magnetic field. Magnetic field is constant. and with the same speed v1, it's equal v2, it's equal v3. Which particle travel in the largest circular path? R equal m v over qb. V is constant, Q is constant also, B is constant, all of this constant. We can remove constant and equal and put proportional sign. It means R direct proportional with M. If the mass increases, the radius will increases also. Which one will travel in the largest path, largest mass? It means particle number 1, because particle number 1 has the largest largest mass. Number 13, an electron Q equal negative 1.6 times 10 negative 19 coulomb move with the speed is v. The electron enters 0.7 Tesla magnetic field, uniform magnetic field, as shown in the figure. What does the magnitude of the magnetic force? F equal what? As you see in the figure, the velocity and B make this angle between V and B. Theta, it's equal 90 minus 30, it's equal 60 degree. F equal QVB sine theta, angle between V and B. Q 1.6 into 10 negative 19, V 1.4 into 10 power 4, B 0.7 sine 60 degree. 1.6 into 10 negative 19 times 1.4 into 10 power 4 times 0.7 sine 60 equal 1.4 times 10 negative 50 Newton. An isolated segment of wire with a length is L, carries a current of a magnitude, current is I, at an angle, it's theta, with respect to the constant magnetic field with a magnitude, magnetic field is B. What is the magnitude and the direction of the magnetic force F? F effect on the wire or current carrying wire, F equal I L B sine theta. I is 20, L 4.5, B 6.5 into 10 negative 2 sine angle between the wire and the magnetic field 35, 20 times 4.5 times 6.5, 10 negative 2 sine 35, 3.35 or 3.4 Newton. What about direction? My fingers with B, it's to down, as you see, and the thumb with current. Palm hand into the screen or out of the screen? Out of the screen. It means outward. 3.4 out of the page or out of the screen, as you see. Number 15. A charged particle enter a uniform magnetic field with a speed v. If the magnitude of the magnetic field strength is double, magnetic field strength is double, B2, it's equal to B1. How will the speed of the charged particle change? The speed of the charged particle remain the same. Why remain the same? Because the direction of the velocity changed only. If we have a magnetic field like this, as you see, and we have a charged particle move in this direction with velocity v, there is a force affected on the charge. My fingers into the screen, thumb with V, palm hand up, the force is to up. Only the charged particle move in a circular path with the same speed. With what? The same speed. The speed remains the same, only direction is changing. If I increase this magnetic field, the force increase, not velocity. Okay? It will stay the same. What is the magnetic force on a coil with a radius? Radius is R, composed of 120 turn, number of turn, and carrying a current is I. If the coil is placed in a magnetic field of, it's B, strength. F, it's equal I L B. If we have a circular path like this, L equals circumference 2 by R. We have number of turns, increase number to the equation. So that F equal N multiply I 2 by R, substitute L with circumference, times B. Number of turn 120. I is, where is I? 0.6. 2 by multiply radius 0.3 and magnetic field strength 0.7. Using calculator, 120 times 0.6 times 2 by times 0.3, 0.7, it's 95 Newton. A rectangular coil of 20 turns, number of turns, has 3 centimeter and 1 centimeter dimensions, area equal L times width, multiply 10 to the negative 2 in both, is placed in a uniform B magnetic field as shown in the figure. If the current is I, flow in the coil, what is the magnitude of torque? Torque is tau on the loop and the direction of the rotation. Torque, it's equal bayan sine theta. Theta is an angle between n hat, unit vector, and B. As you see in the figure, current out of this point and in from this point out to in, my finger refer in this direction. This is n hat direction. In hat direction, in this direction. As you see, current out from dot to X. My finger in the right side and perpendicular to the coil. Perpendicular to the coil, it means the angle between N and B. This angle 90 plus 30, it's equal 120 degree. This is N hat. So that torque equal, B is, where is B? 6, I is 2.3, A length width 0.03 times 0.01, number of turn is 20 turns, sine 120, multiply sine 120. 6 times 2.3 times 0.03 times 0.01 times 20 sine 120 equal 0.07. ENG 7.1 times 10 negative 2. 7.1 or 7.2 times 10 to negative 2 Newton meter. What about direction of rotation? The current out of this point, my thumb out of the screen. You see my thumb out of the screen and the finger with B. Palm hand to down, there is a force in this side to down. What about X? X is in. My finger to left also. The force to up in another side. This force to down, this force to up, it make the coil rotate clockwise as you see in the figure. The direction of rotation, not direction of torque, okay? In this question, ask about direction of rotation also. Determine the direction of rotation for the current loop shown in the figure as long as the current flowing in the loop. Dot out of the screen, my thumb out, and my fingers refer to the right side with magnetic field. Palm hand up, the force up. Another point into the screen, My finger to the right, palm hand down, it means force to down. Up, down, it make it rotate in this direction, clockwise also. Question number 19. A coil is composed of the circular loop with a radius r, centimeter divide 100 or times 10 to the negative 2, and 30 wings, number of turn. A current is I, flow through the coil, which is placed in the uniform magnetic field B. What is the maximum torque when theta equal 90 degree on the coil due to the magnetic field. Maximum torque equal بيان only. A is pi r square, B 0.9, I 1.3, A pi r square 0.05 square. Number of turn is 30 wings. 0.9 times 1.3 times pi times 0.05 square times 30, 0.28 Newton meter. Determine the direction of the magnetic field. Direction of the magnetic field on the current carrying wire as shown in the figure. As you see, the force to down, palm hand, it must down, and the finger to the right side. Now, palm hand is up, it's not correct. So that my finger, it must out, as you see. My finger's out of the screen, palm hand down, finger to the right with I. It means magnetic field dot out of the screen. Out of the screen in this direction. Z direction refer out or in of this screen. It means in the direction of positive Z. Now we make a revision about whole chapter 7. Chapter 7 may be in bonus question. I hope it's useful and there is a benefit from this quick revision. Wait me in EOT revision.